Hey everyone, this is JD from NGen Squared. Today we're going to show you how to do robot inverse kinematics in Unity using the realvirtual Pro asset. This will work for most 6-axis robots that have axes 4, 5, and 6 aligned. This tool is a work in progress, has some limitations. The main purpose of it is to make nice, smooth concept animations within Unity. When we do virtual factory designs, we actually link these Unity models to robotic. That's what we rely on for robot programming. So nonetheless, this model setup will be usable in robotic as well. In this case, we're using a Kuka robot. This can work for basically any robot vendor that has axes 4, 5, and 6 aligned. So we're going to show you an example with a Kuka robot here. Downloads are taken from the Kuka Xpert catalog, so step files, parasolid files, and same with the spec sheets. Most robot vendors will have these. This is for finding the distance between each axis, angle limits, and speeds. In another tutorial, we'll get into the mounting flange and setting up tools according to that. This will be part of a series for construction, automation, robotics. So stay tuned, subscribe if you want to see more tutorials like this. So we're going to go ahead and delete all of this right here and start this from scratch. So we're gonna drag and drop the CAD file. We can do another tutorial later where we show you how to break the CAD files up into separate parts. Sometimes they're not always super convenient. So we have some tips and tricks for that. So we're gonna go to the realvirtual professional IK folder, and then we're gonna drag and drop this empty structure right here for robot kinematics. So as you can see, this is fully preloaded with all the right game objects for each independent axis. It makes setup a lot simpler when you're doing this for multiple robots. We got the robot path game object as well. So we're gonna unpack this first. Make sure to have these unpacked. Also make sure to have your toggle tool handle position set to pivot and your axis system set to local. We'll start with taking these empty objects and positioning them to the right dimensions here. So this will be different for every robot. We're going to go ahead and add these dimensions over here. So axis 2, this is 575, this is 175. Axis 3, this is 0.89. These are set up to be relative, so each axis game object is a translation from the other. So you don't have to do the math to add them all up. This one was 1.035, and this last one is 185. And keep in mind unit conversions when you're in Unity, it's in meters by default, and most of the spec sheets will have millimeters. You want to be mindful of that. So yeah, the next step here is we're gonna get the robot to match the orientation of the empty game object. So we'll go ahead and rotate this to the right position. So that's all set up there. We're gonna rotate the TCP so that it's the Z axis going forward. And then we're gonna expand the kinematic parameters here and click calculate kinematic parameters. So we can see we have no TCP defined, so we'll go ahead and define that. And then this is the default robot path that comes up, so it's a good test when you're setting up a robot. There might be, for some robots it might be out of reach, so you're gonna have to modify these target positions in that case, but we'll go ahead and add this as the home position at start. right here. So we'll go ahead and click this and we'll see if we got it to work. So it seems like it's aligned here. So we'll go ahead and click back on the robotic game object. So we'll go ahead and drag the CAD objects now into the empty folders. We'll pick the fixed components first. So we got here part. Make sure, I believe part 5 is part of it. That's part A1. It's also part A1. There we go. So these are the fixed components. We're going to drag this into the base folder here. So we can see if we collapse axis 1, those are under base. We can put it here just to make sure so we don't get too confused with the order. Next we'll find the objects for axis 1. It's going to be that motor, this, and that other motor there. We'll put these under axis 1. We'll do the same thing here where we bring them up there. Axis 2 should be a lot simpler. This one, it's a nice piece right there. We'll drag that in. Same thing, we'll bring it up. Axis 3. Axis 4. Five. Oh, we put this in the wrong spot, so we're gonna have to put this under 5 right there. Then axis 6. So now we should be set up. We'll go ahead and test the path again. So you can see now it's working. We'll go to the pick position, snaps on there. Place position snaps on as well. So these are just the default positions set up with the folder. So we're gonna create some custom paths here, and we'll show the robot moving. We'll call this path 1, and then we'll rename this to the name of the robot. So KR70 R2100 in this case. We'll delete that empty folder from the CAD import. This thing here, you can scale it down. Yeah, there we go. So we'll click 0 position here. We'll go back to the main path file, and we will click add new target to path. So that created a game object called target 8. So now this is something we can move, and you can see the robot updates, all these parameters update here. So basically wherever we leave this game object, that's where the target gets positioned. You can see the target's position up here in Unity globally. So yeah, basically you can just keep adding a bunch of targets. So now we got target 9. We'll go back here, add another target, target 10. Target 11. So now we just added that movement right there. So we'll go ahead and delete those pick and place positions. So we just kept our paths that we added. Now in each target here, we can change some settings. So we're gonna go point to point for the first target. And you can see our home position is also point to point. Target 9, we will do linear position, target 10 linear, target 11, we will leave it as point to point. So yeah, that's the basics of the kinematic movement, inverse kinematic setup in realvirtual. So now that we have this set up, we're ready to hit the play button. We'll go click play right here. So now you can see the robot is moving according to the targets that we set up, all within Unity. Now it's repeating path 1 in a loop. If you enjoyed this tutorial, hit the thumbs up button, subscribe, and stay tuned for more tutorials. We have a bunch of design and manufacturing content coming in the near future in relation to robotics and construction, construction simulation, and design for manufacturing and assembly.